Hey, Arnold!
Yes, Dad?
Yes. Son, I think it's time that we had the talk.
What talk?
The talk. About space.
Dad, what's space?
Well, son, you ever look out at the night sky and see thousands and millions of stars?
Well, no, Dad, I've never been outside.
And that's the way it has to be.
But Dad, I want to go outside. I want to see the world.
Fine, damn it, we'll go to space.
Seatbelts, everyone! Please let this be a normal field trip.
With the first? No way!
Oh!
You should understand that you're the next at home school. Next thing that you know, you're seeing 55 miles to the gallon. Surfing on gravity waves, ripples in space-time. Take a left at Mr. Nelson. Take a second right at Spotlight the Magic Prius. Step inside, see a wild ride, come on! Ride the Magic Prius!
Are you ready to go into space, Philip?
Oh, I don't know, Dad.
Just close your eyes, son, and we'll be in space in no time at all.
Are we really in space?
Of course we are. Look at all that space.
What are we gonna learn about space first?
Probably the most simple topic I know about space. Relativity.
Who came up with the idea of relativity?
Albert Einstein.
When?
Special relativity was introduced in Einstein's 1905 paper on the electrodynamics of moving bodies. General relativity is a theory of gravitation developed by Einstein in the years 1907 to 1915.
What's the difference?
I'll talk about that in a minute.
So what is the theory of relativity?
Well, there's a lot of different pieces to it, Philip. It's rather complicated. I'll just give you a brief breakdown. Do you know what space is? Actually, Philip, my boy, I am referring to the dimensions of space. There are 1, 2, 3 dimensions of space.
No way.
But did you know that there's a 4th dimension? Time. Time is like an arrow. It's always going forward.
Is the arrow the same for all of us?
Well, sort of. Einstein's theory of relativity says that time doesn't flow the same for all observers.
What does that mean?
Einstein said that space and time are 2 sides of the same coin. One can't exist without the other. In order to fully explain myself, we're gonna need to make a pit stop at the moon!
Really, Dad? The moon?
Yes, son, we're here.
Wow, Dad, is this really the moon?
Yes. This is a moon man. He'll be helping us with our experiment.
Imagine space-time as a giant fabric. Now, when you drop a massive object onto the fabric, it warps space-time. And say you drop another massive object, well, they're going to be attracted to each other, so they'll slide in. This is a 2-dimensional representation of gravity according to Einstein's relativity. So is a black hole when the mass is so great that space-time folds into an infinitely dense point?
Well, yeah.
Neat.
What do you think of that? Now I suppose you'll want to know why it's called the theory of relativity. According to the special theory of relativity, it is impossible to say that in an absolute sense that 2 distinct events occur at the same time if those events are separated in space. So 2 observers might see the same event happening in different ways, depending on where they're standing.
But why? That goes against all common sense.
The universality of physics means that different viewers will see the timing and spacing of events differently. What for us is a million years may just be a blink of an eye for someone flying at a high-speed rocket or falling into a black hole.
So are there any exceptions to that rule?
I'm glad you asked. There actually is. Well, the speed of light, no matter how fast you're going, will always be the same.
Dad, why?
Imagine that you have 2 clocks, a stationary clock and a moving clock. The moving clock will experience time more slowly than the stationary clock because the moving clock is bending space-time as it moves. Another way that this can happen is by gravity with massive objects.
What does that mean?
For example, if you were near a black hole, you might experience 1,000,000 years just like that, because it's bending space-time so dramatically.
Dad, relativity's scaring me. Let's go home.
I never expected you to understand. Let's go home.